What is viscosity?
A property describing the consistency of a fluid by its ability to be deformed by stress. This is related to its ability to flow.
What is precision?
Precision describes how reproducible a measurement is. Regardless of whether the observed value matches the true value. Measurements can be very precise even if they are not perfectly accurate. For example, if you weighed yourself on a scale that was offset by 5 kilograms, you would always be off by the same amount, but you would not be measuring your real weight. So despite not being accurate, the value you obtain could still be very precise. This will generally be true in situations involving a systematic error that is simply a constant offset from the actual value.
Has a Nobel Prize ever been awarded for a discovery in the field of green chemistry?
Yes. Although green chemistry is a relatively young field, one Nobel Prize has already been awarded for work in this area. This prize was awarded in 2005 to three men: Robert Grubbs of the California Institute of Technology, Richard Schrock of the Massachusetts Institute of Technology, and Yves Chauvin of the Institut Français du Pétrole, for their work in the development of olefin metathesis reactions. Olefin metathesis is a type of chemical reaction that involves two carbon-carbon double bonds reacting to form two new carbon-carbon double bonds, effectively exchanging the substituents attached to each carbon. This reaction takes place catalytically under mild reaction conditions, produces little hazardous waste, and has been shown to be effective in a broad range of situations, including the synthesis of new drugs.
Why did Herbert A. Hauptmann and Jerome Karl, both United States, win the Nobel Prize for Chemistry?
For their outstanding achievements in developing direct methods for the determination of crystal structures. These two men won the prize for developing improved methods of analyzing crystal structure diffraction patterns to yield molecular structures. Their method was based on developing probabilistic equations relating the chemical structure to the observed diffraction patterns, and it relied on measuring many diffraction patterns to determine the molecular structure.
Are the north and south poles of the Earth magnetic poles?
Without getting too technical on the physics here, it gets way more complicated with the whole planet versus a tiny piece of iron on your fridge. Yes, the north and south poles are magnetic poles. but compasses point north. So what we call the North Pole is actually the South Magnetic Pole and vice versa.
What is the difference between a homogeneous and heterogeneous mixture?
A homogeneous mixture is one that is uniformly mixed and has the same proportions of components throughout the mixture. An example is a transparent solution of sugar dissolved in water. Specifically one in which there is no undissolved sugar floating around. A heterogeneous mixture is one that is not consistent or uniform throughout, such as a glass of sugar water with some chunks of undissolved sugar also floating around.
What is the 18-electron rule?
Earlier we talked about the octet rule, which says that elements like carbon and oxygen are most stable when they have 8 valence electrons. For transition metals, as we've mentioned, the d orbitals start to become important. So 8 electrons just aren't enough anymore. Since there are 5 d orbitals, we need an additional 10 electrons to fill the valence shell. And 8 plus 10 equals 18, hence the 18-electron rule for transition metals.
What is the third law of thermodynamics?
The most common statement of the third law of thermodynamics is that the entropy of a perfectly crystalline system approaches zero as the temperature of the system approaches zero. Recall from macroscopic properties. The world we see that a perfect crystal is a regularly ordered lattice of atoms that exist in a repeating pattern in 3 dimensions with no defects or irregularities in the lattice. This is equivalent to saying that a perfectly crystalline system has only one accessible state as the temperature approaches zero. In truth, this isn't always strictly true since there can be multiple low energy states that all have the similar energy, but let's ignore this for now.
What is a chromatography?
A process to separate mixtures, generally by differing affinities of to a solid stationary phase.
How do living things store fat?
Fat is stored in a type of tissue called adipose tissue. This is made up of cells called adipocytes that store lipid molecules to be used for longer-term energy storage.
What is graphene?
In one sense, graphene is an unrolled carbon nanotube, or a flattened buckyball. Graphene is a material made of carbon atoms arranged in a hexagonal, honeycomb lattice. It is similar to graphite, except that it is only one sheet of atoms thick. A square meter of graphene weighs less than a milligram. Since its discovery, graphene has garnered significant attention for its electronic, thermal, optical, mechanical, and other properties. There is currently a huge amount of research into the properties and applications of graphene. And one Nobel Prize has been awarded, the 2010 Prize in Physics, for research into its properties.
What does hydrophobic mean?
A nonpolar molecular that does not interact with water.
How can I observe the effects of electrostatic forces using household objects?
Chemistry principles encountered in this experiment: electric charge, electrostatic forces, materials you'll need: nylon hair comb, or a latex balloon, a water faucet. The procedure: comb your hair with a nylon comb. If you don't have a comb, you can also rub your head with an inflated latex balloon instead. As you rub the comb or balloon to your head, it builds up an electric charge on the object due to the movement of electrons between the object and your head. Go to the faucet and turn it on so that a narrow stream of water flows out. Try to make the stream as thin as possible, while still maintaining a steady, smooth flow of water. With the water running, move the comb or balloon close to the stream of water. But be careful not to actually let the comb or balloon touch the water. As it gets close, the stream of water should be deflected toward the comb or balloon. This is because the charge in the object, comb or balloon, induces an opposite charge in the nearby water. And the object and water then experience an attractive electrostatic interaction: opposites attract. You can experiment with how the amount of deflection varies with the size of the stream of water from the faucet. You can also compare the ability of various objects, different combs, balloons, or different objects altogether, or vary the amount of time you rub the object in your hair.
Brown, United States, and George Wittig, Federal Republic of Germany, win the Nobel Prize for Chemistry?
For their development of the use of boron and phosphorus-containing compounds, respectively, into important reagents in organic synthesis. Brown received the prize for his work with boron reagents in organic synthesis, which also led to the development of organoborans as a class of molecules. Wittig worked with phosphorus, developing a reaction through which a carbonyl could be converted to an olefin. This reaction is today known as the Wittig reaction. The work of both Wittig and Brown resulted in the development of useful reagents that find wide application in organic synthesis even today.
Why did Kenichi Fukui, Japan, and Roald Hoffmann, United States, win the Nobel Prize for Chemistry?
For their theories, developed independently, concerning the course of chemical reactions. Fukui can be credited for the development of frontier molecular orbital theory, which provides predictions surrounding the reactivity of compounds based on the nature of their most loosely bound electrons, or highest energy occupied orbitals, along with the nature of their lowest energy unoccupied orbitals. Hoffmann had completed some significant theoretical work while working with Woodward years earlier, and had reached conclusions surrounding the relationship between chemical reactions and the symmetry of the orbitals involved in those reactions. Both of these great scientists succeeded in approaching rather difficult problems by attempting to look for generalizations, simplifications, and basic patterns that were common among their observations.
What is an indicator?
A substance that undergoes an observable change in response to a chemical input, e.g., pH, redox, presence of a metal ion.
What is an oxidation/reduction reaction?
Oxidation and reduction reactions are chemical processes that involve the transfer of an electron between two species. Oxidation is the process of taking an electron away from a species. So if a molecule loses an electron, it has been oxidized. Reduction is the process of giving an additional electron to a species. So if a molecule gains an electron, it has been reduced. Oxidation and reduction reactions are particularly important in the field of electrochemistry.
What is an X-ray?
A form of short-wavelength electromagnetic radiation.
How is O2 transported through the body?
Oxygen enters our body through our lungs in the air we breathe. O2 makes up about 21% of the total volume of air on Earth. From the lungs, O2 diffuses into the bloodstream, where it binds to a molecule called hemoglobin in our red blood cells. The binding affinity of O2 to hemoglobin is pH dependent such that oxygen can readily be picked up by red blood cells near the lungs and then released into tissues and other areas of the body that need it.
What is a black hole?
A black hole is a region of space where the gravitational pull is so strong that nothing, including light, can escape. The size of the black hole is sometimes described by an imaginary surface called the event horizon, beyond which nothing will be able to escape the gravitational pull.
What do the chemical structures of vitamin molecules look like?
Above are the structures of some common vitamin molecules. They typically have a molecular weight in the neighborhood of 100-1500 g/mol.
Why did Max Ferdinand Peretz and John Cowdery Kendrew, both United Kingdom, win the Nobel Prize for Chemistry?
For their studies of the structures of globular proteins. Peretz and Kendrew sought to elucidate the structures of large proteins using X-ray diffraction techniques, with a particular focus on hemoglobin and myoglobin. They took a variety of innovative approaches, including recording a huge number of X-ray diffractions, about 250,000, incorporating heavier gold or mercury atoms at well-defined locations into the molecule, and using a computer, one that was advanced for the time, to process the large amounts of data they collected. This was quite a challenging task, as even myoglobin, the smaller molecule of the pair, contains roughly 2,600 atoms. Their work was the first to help understand the principles behind the structure of globular proteins.
What is an aerosol?
Suspension of a solid or a liquid in a gas, e.g., smoke, fog.
What is a Lewis acid?
A molecule that can accept a pair of electrons.
What is an electron affinity?
The energy change upon adding an electron to a neutral species.
What is a coulomb?
The standard unit of charge, defined as the amount of charge delivered by 1 amp in 1 second.
What is a galaxy?
A galaxy is a huge system consisting of stars, planets, gas, dust, and lots of other interstellar media. The galaxy we live in is called the Milky Way. Galaxies have a lot of stars, smallest have roughly 10 million. while the largest have 100 trillion. All of the stuff in a galaxy orbits around the center of mass of that galaxy.
Is it possible to see a single molecule?
With some of the largest single molecules, like polymers, they can actually be seen by the naked eye or through a microscope. Most molecules, however, are so small that a single isolated molecule cannot be seen with even the best microscopes. There is a physical limitation that prevents their observation with light, which has to do with the size of small molecules, lengths of ca. 0.1 to 1 nanometer, being significantly smaller than the wavelengths of visible light, 400 to 700 nanometers. Other techniques based on diffracting electrons off of molecules, measuring the force molecules exert against a very small metal tip, and other methods have been developed to image small molecules. But it's impossible to see most small molecules with light in the way that we conventionally see things.
Why did Dorothy Crowfoot Hodgkin, United Kingdom, win the Nobel Prize for Chemistry?
For her determinations by X-ray techniques of the structures of important biochemical substances. Hodgkin used X-ray crystallography to determine the structure of penicillin, vitamin B12, and a large number of other biologically relevant molecules. As the importance of computers for processing X-ray crystallographic data was increasingly being recognized, Hodgkin was noted for her exceptional ability to process the data, and the Nobel Committee recognized that this talent likely played a vital role in her ability to achieve so much during her career.
How did chemistry affect trade in ancient times?
Ancient chemistry was involved in the production of many goods that were important to trade. These included salt, silk, linen dyes, precious metals, wine, and pottery.
How long are chemical bonds?
Chemical bonds are typically about 2 atomic radii in length. Since they are formed from 2 atoms joined together, these distances are on the order of 10 to 10 meters.
When did alchemists finally abandon trying to make gold?
In the late 1700s, a scientist named James Price was still hard at work trying to transmute metals into gold and silver. In 1782, he claimed he could convert mercury into silver and gold. At first it appeared that his experiments had worked, but conflict rapidly rose. More and more scientists asked to witness the experiments firsthand. And Price eventually lost confidence in the validity of his own work. After disappearing for a few months, in 1783 he invited scientists to his laboratory to witness his experiments in person, but only a few men showed up. In their presence, Price intentionally ingested a poison, killing himself. He was the last of the modern scientists to claim to have achieved the goals of alchemy. And it is no longer believed that anyone will find a simple way to convert inexpensive metals into gold.
Why did Marie Curie, née Sklodowska, Poland/France, win the Nobel Prize for Chemistry?
For the discovery of the elements radium and polonium. By the isolation of radium and the study of the nature and compounds of this remarkable element. Curie was the first woman to win a Nobel Prize. And she is still the only person to win in multiple sciences. Curie was a professor at the University of Paris. Another first. Why did she was the first woman on the faculty, beginning in 1900, and then at the Sorbonne in 1906, again why did she was the first female professor there. In 1903 she was awarded, along with her husband, Pierre Curie, and Antoine Henri Becquerel, the Nobel Prize in Physics for her work on radiation. In 1910, Marie isolated radium for the first time by electrolysis of radium chloride in the presence of hydrogen gas. This contribution was not enough for the French Academy of Sciences to elect her to their ranks. But a year later this accomplishment was recognized with Curie's second Nobel Prize.
What are metamaterials?
A metamaterial is a type of artificially engineered material that typically features a pattern or periodic arrangement of a material. Metamaterials are characterized by the fact that they take on specific macroscopic physical properties based on their structure or the pattern in which the material is arranged, but not necessarily the composition of the material. Another way to say this is that the elemental makeup of a metamaterial is not as important as the internal structure of the metamaterial. By relying on the structure of the material to influence its properties, metamaterials have been able to achieve properties that haven't been achieved in other types of materials. One example includes materials with a negative refractive index, see physical and theoretical chemistry, which have been able to achieve the first demonstrations of invisibility cloaking over certain wavelength ranges. And this technology will hopefully continue to progress as time goes on.
What is a dative bond?
A chemical bond in which one atom is essentially providing both electrons involved in the bond.
What is bagasse?
After sugarcane stalks are crushed and pressed to remove their juice, the remaining plant matter is known as bagasse. After the water is removed, and bagasse can contain a lot of water. Bagasse is mostly composed of cellulose, hemicellulose, and lignin. Typically this material is burned by the sugar mills directly to generate heat for other processes running at the mill or electricity, which can also be used at the mill or sold back to the electric grid. Bagasse also finds its way into paper production. Recently bagasse has been targeted as a potential source of ethanol.
How and when was molecular chirality discovered?
Non-racemic mixtures rotate the plane of a beam of polarized light in either a clockwise or counterclockwise direction. Jean-Baptiste Biot, a French physicist, observed this effect in 1815 with quartz crystals, turpentine, and sugar solutions. These were important results in understanding the nature of light. But it was Louis Pasteur in 1848 that figured out that the effect was based on molecular properties. Pasteur painstakingly separated enantiomerically pure crystals from a racemic mixture of tartaric acid and showed that the two enantiomers rotated light in opposite directions.
Are all polymer chains the same size?
No. Let's stick with the macaroni metaphor to understand this. Imagine you're stringing noodles together to make a macaroni necklace. You can put as many noodles on a single string as you want. If you have two strings, you can put an equal number of noodles on each string or make one longer than another. Again, the macaroni noodles are monomers, which form polymers when we string them together.
What is molecular orbital theory?
Molecular orbital theory is the other main theory. The first was valence bond theory, used to explain and predict bonding properties in molecules. Molecular orbital theory describes bonding interactions by using molecular orbitals that are spread out over multiple atoms. And this allows an electron's location to be described by an orbital that bonds atoms together in a more realistic way than valence bond theory.
What is saponification?
Saponification is a type of reaction in which the ester functional Groups of triglycerides are hydrolyzed under basic conditions. The term can also refer to the hydrolysis of any ester as well.
What is the Boyle's law?
Law stating that the pressure and volume of gas are inversely proportional.
How does crystallization purify compounds?
Crystallization as a purification technique relies on the fact that it is usually much easier to form a crystal from a single chemical species than it is to form a crystal from a mixture of chemical compounds. Recrystallization is the process of dissolving a crude, impure product in a hot solvent or mixture of solvents, and allowing it to crystallize out of the solution form as the solvent cools. Once a small crystal, even one so small we can't see it, begins to form, it is relatively easy for other molecules of the same compound to add to the crystal. Other compounds will not be able to readily add to this crystal, which results in the formation of a crystal containing a single, pure chemical compound.
How did the first matter originate, and why was it all packed together in a very dense state?
Unfortunately, we cannot answer that one, and neither does the Big Bang Theory. Rather, the Big Bang Theory is only focused on explaining the evolution of the universe, from that initial state to what it is today and to what it will become in the future.
What is an electronic wave function?
A mathematical description used to describe the electrons in a chemical system.
Why do baking soda and vinegar fizz so much when they react?
The chemical name for baking soda is sodium bicarbonate, and its chemical formula is NaHCO3. Vinegar consists mainly of acetic acid, CH3COOH, and water. When baking soda is added to vinegar, the following reaction takes place between the sodium bicarbonate and acetic acid. NaHCO3, AQ, plus CH3COOH, AQ, CO2, G, plus H2O, L, plus CH3COONA, AQ. It's the released CO2 that creates the bubbles and foaming appearance you see when the two are mixed.
What is the first law of thermodynamics?
The first law of thermodynamics is a statement of the conservation of energy, which tells us that energy can be transferred from one form to another but never created or destroyed.
What is a pi bond?
A chemical bond in which two lobes of two orbitals on adjacent atoms overlap favorably.
What makes a fabric waterproof?
One type of waterproof fabric is waterproof simply because the threads are woven so tightly that water cannot easily get inside or through. Other waterproof materials are waterproof because they have been treated with a rubber or some other coating that keeps water out. Some coatings will only temporarily waterproof a material such that the coating or treatment wears away over time and needs to be reapplied.
What is a tautomer?
Structural isomers that differ only in the position hydrogen atoms.
What is a phase diagram?
A phase diagram shows the phases of a particular substance as a function of temperature and pressure. An example for a single component phase diagram, as in not a mixture, is shown above. Phase diagrams also exist for mixtures, but these get very complicated very quickly.
What is an atomic weight?
The average mass of an atom of a given element.
What happens in the cerebellum?
The cerebellum is important for controlling your sense of balance, motion, and your motor skills in general.
Why did Elias James Corey, United States, win the Nobel Prize for Chemistry?
For his development of the theory and methodology of organic synthesis. Corey was awarded the Nobel Prize for his numerous important contributions to organic synthesis, including the development of theories and methods that allow for the production of biologically active natural products. This led to many pharmaceuticals becoming commercially available, and thus had a clear impact on the general public health. His research was likely so successful because he developed the principles of a methodology known as retrosynthetic analysis, in which one starts with the structure of the target molecule and analyzes in reverse order what bonds must be broken to generate simpler structures that one can already synthesize readily.
What is an herbal medicine?
Herbal medicines are any plants or plant extracts used for treating ailments, aches, pain, or discomfort. They can range from culinary remedies, like chicken soup for the common cold, to calming extracts, like mint tea, to eating whole herbs. Every ancient civilization seems to have discovered the use of plants as medicines in one form or another. Even as far back as 5,000 years ago, humans were using herbal medicines, as evidenced by herbs being found alongside well-preserved, mummified humans like Ötzi the Iceman.
How do mirrors reflect light so well?
Most modern mirrors are made of smooth layers of silver or aluminum, along with other chemicals and coatings to aid in their construction. While the chemical properties of silver play some role in reflecting light, the fact that these layers are very, very smooth is more important here. If the surface of the silver layer were rough, the light would be reflected in a variety of different angles, which you would see as a distorted image. When the surface is perfectly smooth, the light bounces straight back into your eye and you see an accurate reflection of the object. This is why you can see clear reflections in very still water or a shiny piece of leather. Both are smooth surfaces.
What is a bond order?
Number of pairs of electrons shared by two atoms.
What is energy?
In chemistry, energy serves as the currency for making or breaking chemical bonds and moving molecules, or matter, from one place to another.
How do scientists determine how far away a star is?
The answer to this question lies in the application of trigonometry. An astronomer can look at a star at a given point in time and then look at it several months later, after the Earth has moved a substantial distance in its orbit around the Sun. This allows the astronomer to view the star from two different angles. By comparing the images from the two different angles, it is possible to figure out how far away it is. If a star happens to be too far away, the first method described will not be accurate. But fortunately there is an alternative. If an astronomer measures the visible light spectrum of the star, it turns out that one can get a good idea of its actual brightness. By actual, we mean how bright the star is if you are right up close to it. This relationship isn't entirely straightforward and has only been established after looking at data from thousands of stars. Once the astronomer knows the actual brightness, its brightness can be compared by its apparent brightness as viewed from Earth to determine how far away it is.
What is infrared spectroscopy?
Infrared spectroscopy is carried out using somewhat higher energy electromagnetic radiation. 300 GHz to 400 THz, than microwave spectroscopy. The infrared region of the spectrum is usually a good match for the vibrational energy level spacing in molecules. So infrared spectroscopy is typically used to study the vibrational energy levels of molecules. Vibrational spectroscopy can be used to study molecules in the gas, liquid, and solid phases, as well as molecules on surfaces.
How many different conformations can a protein adopt?
A lot. For a typical protein consisting of 100 amino acids, there are approximately 3,198 possible conformational states. This leads to something called Levinthal's paradox, which has to do with how a protein goes about sampling each of these possible states. If a protein just randomly went through each of 3,198 possible states, it would, on average, take longer than the age of the universe to get through all of them. Fortunately, proteins don't sample each of the possible conformations randomly. Instead, the gradient, or slope, of the energy along the folding pathway, along with the formation of local interactions between the amino acids, guides the protein toward states of lower energy. This allows it to avoid sampling most of the unimportant conformations as it folds toward its native state.
What is osmosis?
The diffusive process of solutes moving from areas of higher concentration to lower concentration.
Why did Johann Diefenhofer, Robert Huber, and Hartmut Michel, all Federal Republic of Germany, win the Nobel Prize for Chemistry?
For their determination of the three-dimensional structure of a photosynthetic reaction center. This prize was awarded for the atom-by-atom characterization of a membrane-bound protein. And, in particular, one that is responsible for carrying out photosynthesis. These proteins are quite difficult to crystallize, and Michel can be credited with achieving this task. He then collaborated with Huber and Diefenhofer to unravel the details surrounding the structure of the crystallized membrane-bound photosynthetic reaction center.
What is metallurgy?
Metallurgy is the branch of science that deals with the properties of metals composed of both pure elements and those of mixtures of metallic elements, which are called alloys. It represents one of the first efforts to manipulate and understand how elemental composition of a substance affects its physical properties.
What is the yield for a reaction?
The yield of a chemical reaction is the amount of product that is produced. An example might be 2 grams. It is often of greater interest to consider the percent yield, which describes the amount of product formed relative to the maximum amount of product one could have expected based on the quantities of reactants used. The percent yield provides a measure of how efficient a process is for producing the target product.
What is an analyte?
An analyte is simply the chemical species whose properties we are trying to measure in an analytical chemistry experiment. Most often, analytical chemists are interested in measuring the concentration of an analyte present in a sample. The measurement of an analyte concentration is a quantitative observation.
Is there a reason all amino acids in biological systems share the same chirality?
While the answer to this question is uncertain, there have been some interesting developments in this area. It has been shown that life, as it exists today anyway, cannot arise from a racemic mixture of amino acids because the presence of chiral centers in many biomolecules is crucial for biological function. The self-replication of DNA relies on the presence of chiral centers and without a shared chirality, the error rate in DNA replication would cause severe problems for many longer-lived plants and animals. One hypothesis for the origin of chirality is that molecules from outer space reached Earth with a net chirality already present. Another is that the net chirality in amino acids was established on Earth in a very short period of time. It's a pretty interesting thing to think about, and this topic is a subject of ongoing research and debate.
What is a heteroatom?
Any atom other than carbon or hydrogen.
What is a metal?
An element, compound, or alloy that is a good conductor of heat and electricity. Also usually reflective, ductile, and malleable.
What is the ionization energy of an atom?
The ionization energy of an atom is the amount of energy it takes to remove an electron from the atom. The process of removing an electron leaves the atom with an extra proton. relative to the number of electrons, and thus creates a positively charged ion, known as a cation. The ionization energy can be thought of as a measure of how strongly an atom holds onto its electrons. In general, ionization energies increase from left to right across a period, though there are exceptions. Due to an increasing number of protons to attract electrons in the valence shell. Ionization energies decrease going down a group in the periodic table. Due to the valence electrons being farther from the nucleus, and thus more shielded from its positive charge. Note that the trends in atomic radii and ionization energy go in the same direction. Larger atoms tend to have lower ionization energies.
What is a reactant?
A compound that is consumed or transformed by a chemical reaction.
Where was early chemistry developed?
While many civilizations learned how to make dyes and pigments, or ferment fruit into wine. The earliest theories about atoms and what makes up the chemical world came from ancient Greece and India. Leucippus in Greece and Kanada in India both came up with the idea that there must be a small, indivisible part of matter. The Greek word for uncuttable is atomus, clearly the root of the modern term atom. Kanada's term for this similar concept was paramanu or simply anu, the indivisible element of matter.
What is the role of the EPA in promoting green chemistry?
The United States EPA, or Environmental Protection Agency, has taken great efforts to promote green chemistry. The EPA offers numerous scholarships and awards to promote awareness of green chemistry and the observation of green principles in the chemical industry. It also undertakes efforts to educate the public on green chemistry and, more generally, on the effects of chemical products on human health and on the environment. The EPA also funds research on sustainable technologies and small business innovation, as well as the American Chemical Society Green Chemistry Institute, which promotes partnerships with chemical industry.
What is the pH?
A measure of the hydrogen ion concentration of a solution.
Why did Alan J. Heeger, United States, Alan G. McDermid, United States/New Zealand, and Hideki Shirakawa, Japan, win the Nobel Prize for Chemistry?
For their discovery and development of conductive polymers. This prize was awarded for the discovery of plastics/polymers that can under certain circumstances, be made conductive. This was quite a surprising result, since nobody ever expected plastics to be conductive materials. These plastics/polymers consist of chains of conjugated carbon-carbon double bonds. In other words, carbon-carbon double bonds that alternate with carbon-carbon single bonds. These polymers were also doped, which means that electrons were either removed or added artificially by oxidation or reduction.
Why does the inhalation of helium make voices higher?
After you inhale helium, your voice might sound higher, but the pitch or frequency of the sound waves is exactly the same. Your vocal cords vibrate at the same frequency because your body doesn't adjust for the presence of a less dense gas in your throat. What does change is the speed of sound in helium versus air, because helium has a lower molecular weight than air, the speed of sound is higher. You've probably heard this is because helium is less dense. That's not technically correct, but let's not go there.
Can multiple liquid phases exist for a mixture?
Yes. One familiar example is a mixture of oil and water. The immiscible oil and water phases are two different phases of liquid matter.
What's in toothpaste that makes our teeth cleaner?
If you get your teeth whitened at the dentist or buy some over-the-counter whitening products, the active ingredient is usually hydrogen peroxide. The hydrogen peroxide reacts with the colored molecules that are staining your teeth to remove them or at least make them colorless. This can be a slow reaction, so at the dentist's office, sometimes they use a bright light to speed up the breakdown of the H2O2. If you're wondering about whitening toothpastes, those contain an abrasive compound that simply rubs the stain molecules off of your teeth. No fancy chemistry at all.
What causes the glow in glow sticks?
Glow sticks contain three main components: a diphenyl oxalate, and hydrogen peroxide. The hydrogen peroxide is the chemical you release when you crack or activate the glow stick. Diphenyl oxalate reacts with the hydrogen peroxide to generate a molecule called dioxydenedione. This particular molecule decomposes to release two molecules of carbon dioxide and energy that excites a di molecule to a higher energy state. To get back to its stable state, the di releases a photon of light, making your glow stick glow. The particular structure of the di molecule controls the wavelength, color of this light, which is how you can get glow sticks in different colors.
Leloir, Argentina, win the Nobel Prize for Chemistry?
For his discovery of sugar nucleotides and their role in the biosynthesis of carbohydrates. Leloir discovered a substance essential for the transformation of one sugar into another. And this turned out to be a sugar bound to a nucleotide molecule, a sugar nucleotide. He soon realized that he had opened the door to a vast number of unsolved problems surrounding carbohydrate synthesis, and proceeded to pursue them with fervor. During his career, Leloir revolutionized the understanding of the synthesis and biosynthesis of sugars.
What is the Big Bang Theory?
The Big Bang Theory is a model that attempts to explain how the universe was formed. This theory suggests that the universe as we know it came into existence a little less than 14 billion years ago, and that everything started from a very dense, hot state from which the universe as we know it began to expand. This theory is based on, and is consistent with, all of the current observations we have surrounding the known universe, such as the fact that it is expanding, or that there exists a large abundance of light elements in the universe. The one thing left unexplained by this theory, though, which you may likely be wondering about, is how that initial state came to be in the first place.
What is crystallography?
Crystallography is the study of the arrangement of the atoms in a solid material. Today, this term generally refers to methods that rely on the patterns of photons. Commonly, X-rays, neutrons, or electrons that are diffracted after impacting a sample. The patterns of the diffracted radiation or particles can be interpreted to determine the structure inside the crystal. The interpretation of the diffraction patterns to yield a chemical structure is by no means a simple task. But crystallographers have been doing this for a long time, and it has become a commonplace technique. Crystallographic methods have been used for decades to study the structures of inorganic solids and organometallic complexes. We point out that, while crystallographic methods are commonly used to study inorganic compounds, they have also frequently been applied for studying other types of molecules as well, including biomolecules. While it can often be difficult to obtain a crystalline sample of a biomolecule, such as a protein, crystallography can be extremely useful in deducing protein structures.
What are interferences?
Interferences are substances that interfere with the measurement of the analyte we are interested in. They give a similar response to our analyte in whatever analytical measurement we are making. Typically, analytical chemists want to remove any interferences from a Sample prior to making a measurement, or, alternatively, choose the method of analysis carefully, so as to avoid any signals caused by interferences.
How can I inflate a balloon using yeast?
Chemistry principles encountered in this experiment: biochemical/enzymatic reactions, gases, materials you'll need. Yeast, 5 to 10 grams powder yeast, a small plastic bottle, preferably about 16 ounces. Or smaller, 1 teaspoon of sugar, a balloon, warm water. The procedure: add enough water to a small plastic bottle to fill it up about 1 inch. The water needs to be warm for the yeast to do its job. Add about 5 to 10 grams of yeast, 1 small packet will do, to the bottle, and mix it around well. Yeast is made of fungal microorganisms that will become active when placed in the warm water. Add a teaspoon of sugar to the water. The sugar serves as the food for the yeast microorganisms. They are going to consume it and produce carbon dioxide gas as a byproduct. Wrap the balloon around the open end of the bottle. You may wish to use tape or a tight rubber band to prevent gas from escaping. Let the yeast do their job for about 20 minutes. And the yeast should soon produce enough carbon dioxide gas to start filling up the balloon. This is the same thing that happens when you use yeast to bake bread. The little holes you see in the bread are from the yeast releasing carbon dioxide as it rises. Try repeating the experiment using different amounts of water, sugar, and yeast, and observe the rate at which the balloon inflates. One hypothesis you might test is whether the concentration of sugar in the water affects the rate of carbon dioxide product. You might also try varying the amount of yeast you use. Pay attention to both the rate at which the balloon inflates, and the final volume of gas it reaches.
What is liquid smoke?
It's actually exactly what it sounds like, as crazy as that is. Smoke from a wood-burning fire is blown into condensers, which collect many of the volatile chemicals in smoke. This mixture is then diluted with water. It's used to cure bacon and flavor many other foods.
Why did Svante August Arrhenius, Sweden, win the Nobel Prize for Chemistry?
For his electrolytic theory of dissociation, Arrhenius began studying as a graduate student at the University of Uppsala how much electricity solutions of various molecules could conduct. He correctly proposed that solution of salts were conductive because the salts formed charged particles, later named ions, even in the absence of an electric current. His advisors weren't very impressed, and he earned a third-class degree in 1884. Arrhenius continued to develop the work. and was soon awarded the Nobel Prize for his insights.
What is an anode?
The electrode at which oxidation occurs.
What is an elimination reaction?
If an addition reaction adds two groups to a molecule, then an elimination reaction takes them away. The textbook example again involves carbon-carbon double bonds. But this time we're making that double bond. A molecule of base, hydroxide ion, O, causes the elimination of HBr. In this case, the process happens in one step, as shown.
What causes non-stick pans to be non-adhesive?
Non-stick pans and other surfaces are coated with a polymer that does not interact strongly with other surfaces, hence, no sticking. Teflon, R, developed by DuPont, R, in the 1940s, is most frequently used for this application. Teflon, R, is a polymer of tetrafluoroethylene, which is very hydrophobic. So water or any other substance, like food, doesn't stick to it. More recently, other polymers have also been developed for this application. Thermalin, R, is a silicon oxide polymer with some similar properties to Teflon, R. And Ecolon, R, is a nylon-based product that is reinforced with ceramics for toughness.
What is electron paramagnetic resonance spectroscopy?
Electron paramagnetic resonance, EPR, spectroscopy, also known as electron spin resonance. ESR, spectroscopy, is a method used to probe unpaired electrons in a molecule. This method is fairly similar to nuclear magnetic resonance, NMR, see the modern chemical lab. But it involves exciting electronic spin states instead of nuclear ones. One downside to this technique, relative to NMR, is that the majority of molecules do not contain unpaired electrons and thus cannot be studied using EPR. On the other hand, the lack of interfering signals from most solvents and other molecules can very often be an advantage for the same reason.